Okay, in this video we actually want to begin to graph linear equations using the slope-intercept form. So in the previous example, in the previous video, we saw that we could identify what the slope and y-intercept of an equation was if it was already in slope-intercept form. So here we can see that the slope is 4. That's the number that's multiplied times x, and we know what the y-intercept is. The y-intercept is -4, and that's the place where the graph crosses that's the point where the graph crosses the y-axis. So how do we go about graphing these equations? First, we're going to start by plotting the y-intercept. All right, let me step back 1 second. And let's see if I can list some strategies here. The first thing we need to do is to write the equation in y equals mx plus b form. Well, in the first equation, that's no problem. In the second and the third, or in problems 10 and 11, that is a slight issue there. So first we're going to have to write it in y equals mx plus b form. Second, we want to identify the slope m and the y-intercept b. Third, we're going to plot the y-intercept. And fourth, we're going to use the slope to plot additional points and fifth, finally, we're going to draw a straight line through those points. So we want to make sure that our equation is in y equals mx plus b form. If it's not, we want to rewrite it as so. 2, we want to identify the slope m, the y-intercept b, from the equation itself. Third, we're going to plot the y-intercept. So that would be to plot the point x is 0, y is b. Then we're going to use the slope to plot additional points. And finally, we're going to draw a straight line through the points. So let's see what that looks like here. First of all, we want to plot the point y is equal to -4. Sorry, that's not a point. Y is equal to -4. X equals 0, y equals -4. Or plot the y-intercept, which is at y equals -4 on the y-axis. Now, the slope, how do we use the slope? The slope tells us, the slope says m is equal to 4. Now, when you're actually plotting, you may want to make sure that you have a fraction there. And if it's a whole number, you just divide by 1. What that tells you to do is to go up 4, 1, 2, 3, 4, and over 1, and we would have another point there. And we could continue to do that. Up 1, 2, 3, 4, over 1, and we would get another point there. At which point, we could simply draw our straight line as straight as possible. Not very good. And that's a little bit better. All right, so that's how we would do that. We would first make sure the equation is in y equals mx plus b form. It is. We identify the slope, 4, or 4 over 1. We identify the y-intercept on the y-axis, -4, or the point, that y-intercept should have been -4. So I rewrote that there. So we plot the y-intercept. Then we use the slope. The slope says go up 4 over 1. So we go up 4 on the y-axis over 1. We can still go up then up 4 over 1, and we can continue to do that as long as we are able to. Alright, what I'm going to do next is then scroll up, and we're going to solve we're going to graph the equation in number 10. Okay, so problem number 10, we want to graph this equation. The issue that we have here is that it is not in y equals mx plus b form. It's not far, but it's not there yet. So the first thing that I want to do is to rewrite this in y equals mx plus b form. 1. So 3x plus y is equal to negative 3. First thing I'm going to do, subtract 3x on each side, subtract 3x on each side, and I get y is equal to, remember I'm going to put my x term first, and I can't combine negative 3 and negative 3x. The best I can say is that y is equal to negative 3x minus 3. And so that is my equation in slope-intercept form. The slope, you note, is the number multiplied by x. That is negative 3. The y-intercept is the number that's added to the end, so that would also be negative 3. Or we could say it is the ordered pair 0, negative 3. So what I want to do here is to plot my y-intercept, which is negative 3. Now, the slope tells me to go down 3 over 1, but you'll notice that I run out of room when I do that. So, if there's no room on the graph to go down 3, right 1, you can do exactly the opposite of that and go up 3, left 1. So I know this may be a little complicated. We always have said we're going to move from left to right, but sometimes you run out of room on your grid, and if you do exactly the opposite of both, instead of moving down, we move up. Instead of moving right, we move left. And that will give us a point that lies on the same line, as if we were going down 3 and right 1. So down 3, right 1 might appear over here. But watch what happens if we go up 3, left 1, we would get this point here. And that point is just as good. You'll notice that it lies on the same line. And we can continue that pattern, go up 3, left 1 again, and we'll run out of room there as well. So I can draw the line through that then. Alright, now I forgot that this asked us also to identify the x-intercept. And the x-intercept here is the place where the line crosses the x-axis. X-intercept would be the point x is negative 1 and y is 0. In the previous example, I'll fill it in on the printout, or on the hard copy. Actually, we'll go back and look at that one. We were to identify the x-intercept here, and you can see that the x-intercept, the place where the graph crosses the point where the graph crosses the x-axis, would be x is 1, y is 0. Alright, we'll go on to problem 11. Alright, let's talk about problem number 11. Now, one thing that I would mention before I go any further is this, that we never want to forget what we've learned in the past. And in the last section we learned about equations that were in standard form. So standard form again is ax plus by is equal to c. And if you look at this particular equation, it is in standard form. And to me, if an equation is in standard form, it might be easier to graph it that way than to solve this for y equals mx plus b and to identify the slope and intercept and then to graph it that way. So when will it be better? It will be better if your x and y intercepts are whole numbers that lie right on the grid there. So I'm just going to really quickly go through an example so we don't forget what we learned in the past. And if we had x plus 2y is equal to 6. Remember, x-intercept is the place where y is equal to 0. And in this equation, when we set y equals 0, we get x equals 6. Remember, that's not the line x equals 6. That is the point x equals 6, y equals 0. And second, the y-intercept would be the place where x is 0. And when x is 0 in the equation above, we'd have 2y is equal to 6, y is equal to 3 then, and we'd have the point x is 0 and y is equal to 3. Now, I do notice a problem here. One problem is that my grid for the x values doesn't go up to 6. So that is going to be a problem in graphing here. I would have to go out another line to say 6 over here and plot my y-intercept. Sorry, my x-intercept at 6, 0. The y-intercept does show up, and so I would get these 2 points here and draw a line through them. And get a line that looks something like that. Now, I'm not a big fan of drawing off of the grid there because, you know, you can't measure it exactly, but it's not bad. Now, let's see how we would graph that the new way, or the way that we've learned in this section here. We need to solve that equation for y, or put it into y equals mx plus b form. So to do that, we have x plus 2y equals 6. I need to isolate the y, so I'm going to subtract x on both sides. And I end up with 2y is equal to negative x plus 6. I want to divide everything by 2. Everything by 2. And I end up with y, and I'm going to rewrite it the way that I've shown you. Y is negative 1/2 x plus 3. From that we can see that the slope is negative 1/2 and the y-intercept is 3. So what I'm going to do then is plot my y-intercept, and that happens to be right at y is equal to 3, which we already graphed before. Then I'm going to go down 1 over 2. So down 1 over 2. And you can see that, and if I reverse that and did exactly the opposite, I would go up 1, left 2. So when I say over, I should really be specifying right or left. So down 1, right 2, down 1, right 2. But I could also start at the y-intercept and go up 1, left 2. And from there I could go up 1, left 2 again. So you can see that I can find many more points and be much more confident about my answer. And not only so, none of those points that I graphed are off of the grid, and I could go in and draw that line again. So I hope that makes sense there. When you see something in standard form, if your x and y intercepts can be whole numbers, then go ahead and graph it using the intercepts. If not, then put it into y equals mx plus b form and plot the y-intercept and use the slope to find additional points. Okay, so that'll do it for this video.